everyone. I'm so happy to be here and discuss some of our team's recent work. It's called Beyond Aesthetics to Text-to-Image Models Equally Serve Everyone. And so I am part of the Foundation Research Unit in Google DeepMind, and I mostly focus on multimodal fairness. And this talk is mostly about one of our recent papers, which we'd see on the course. So I'd like to split the 30 minutes I have to 3 main chunks, and then let's also have a little bit of path ahead if time permits, which is more of like literature review on like a lot of different strategies in multimodal fairness, and also be happy to take questions if we get time. Also, we'll be happy to answer questions over email or if you reach out over other platforms. So yeah, starting with, okay, I'm unable to change. Yeah, starting with the first section. So this talk would mostly be about text-to-image models, but towards the end we can see how some of these things generalize to other multimodal models, and that's mostly what we'll be talking about in the first 20 minutes of the session. So yeah, so text-to-image models in 2024, they create really hyper-realistic images, and you must have seen like a lot of demos with T2I models where they have like really hyper realistic prompts, like very detailed prompts and images that are really aesthetic. So that's where T2I models are in 2024, and the interest in text-to-image models or even the techniques underlying T2I models is increasing. Like you see the graph below, it's like huge wave of papers came out that are now like the foundation of image generation models, including text-to-image models, and a lot of these developments are recent. So some of these are great, but there are also like risks and harms associated with these developments. Firstly, these models are very ubiquitous. They're like used by a lot of communities and cultures these days, and they're largely used by even big industries for like advertising, and like it's a form of creative expression. But one thing that needs to be kept in mind is images are really powerful. Images that are generated from these T2I models tend to be seen, and it's possible to download these outputs just from the UI. So studies have shown that visual associations influence basic cognitive process. A very famous paper is cited here. I'd encourage you to take a look. So T2I models, when you give them prompts and you see some stereotypes, and those kind of associations can really influence a lot of basic cognitive process. For example, in this paper, Not Yet Human, Implicit Knowledge, so they show how the judicial system is influenced by a lot of not text-to-image associations, but just associations in the society in general. So T2I models have a lot of contemporary consequence. Another important thing is how the next generation of multimodal data sets there's going to be a huge part of it which is synthetic, and T2I text-to-image models are like the foundation for a lot of these data sets. So now going on to what I would be talking about is a certain term called cultural competency. So I can define it. It's not it's an exhaustive definition, but what we look at in our paper is to see if T2I models can produce culturally diverse outputs, as well as if they are actually aware of global culture, of like different artifacts from around the world. So when you give these models a prompt, which we call as underspecified, which is there is not enough specificity to get the right artifacts, but so there's like a wide range of concepts that can be generated. For example, a high definition photo of a monument. This is an output from a state-of-the-art T2I model. You get like the same monument if you sample different seeds. It's like the same monument with like different views and like slightly different aesthetics and all that. Likewise, on the right, you see there's like a lack of regional diversity. When you ask for image of Nigerian food, there is like it's very, very homogeneous, the outputs. And below you see we have another we go deep down and see if these models can generate a lot of these artifacts. The first thing is lack of cultural awareness. You see that sometimes when you ask for artifacts from different countries, you see they are not so faithful to the prompt. They're even sometimes made very cartoonic, as you see on the right. Like this is an Indian cuisine, and it's there's like leaves on top, and it doesn't really look realistic. So to evaluate these models on like different cultures around the world, it's important that you build evaluation benchmarks. That's how like the ML community like progresses. Like you have a benchmark, you have an evaluation methodology, and then you try to hill climb on that, and then just try to achieve as much as you can with that evaluation set. So the first step is to build such an evaluation setup, and we saw that there is no existing evaluation benchmark on T2I models. So on the left you see a list of text to image benchmarks and the skills that they evaluate on. So the skill is mostly like spatial, like they see like a dog behind a cat or a tree, and all those spatial relationships. There's like composition, color, but there is no skill. I mean, cultural competence is a skill. And likewise, the evaluation aspect has mostly been like faithfulness and realism. There has been some work recently on diversity, like the visual or representational diversity. We should also look at towards the end. So this is the gap we want to fill. We want to basically build an evaluation benchmark that tests the cultural competency, and we also want to motivate diversity. Like when you sample different seeds from these T2I models, do you get a set of images that are like diverse or like representative of that culture? So that brings to us to the first section. So we basically have a framework that we use to build this evaluation benchmark. As you can see, like we use countries as like a proxy for to demarcate culture. Like it's been done it's been done in research. There's like other ways of demarcating culture, like linguistically, or there are other forms, but we stick to geography because of the ease of this definition. And then so we say that we look at a few concepts, and these basically are like one lens that you can view culture from, like landmarks, clothing, cuisine. These are like unique to the different geographies, different cultures here. And what we want to build is, once we have a culture and a concept, we want to build the concept space for this culture concept combination. So when you look at like Indian landmarks, you want like an exhaustive list, or at least to some extent exhaustive list of all possible Indian landmarks. Likewise, we want to build the concept space, like what are all the possible Italian dishes like pasta, pizza. So you want like a good concept space. So in our paper we discuss one yeah, so the method that we use in our paper is automatic. So we have an automatic extraction methodology that scrapes cultural artifacts from Wikidata, which is like a very popular and an open knowledge base. And then we use a language model to kind of do some filtering. So we can look at that in more detail. So I think this slide is a little heavy, so I'll go step by step. So for every concept, we want to get a concept space. That is, we want to get all possible artifacts that can take in the concept. So what we do is a simple traversal of Wikidata. So we basically identify some root nodes that can be representative of a lot of cultural artifacts. And then we traverse. Basically, we do like a depth first search, if you will, to get all the artifacts. And an artifact is defined as something that is a child of these root nodes, and it also has a country property. So a Wikidata node that is associated with any of these countries and is a child of any of the root nodes that we define is defined as a cultural artifact. So we do this process, and then we extract 300,000 artifacts for the 8 countries we saw earlier. So that is like it's a great starting point for us to do these evaluations. But yeah, like since it's automatic, it's prone to errors. So we use we obviously have to do our best to prune out errors or noise. So we just use an LLM to do this large scale pruning out. So we also do like use LLMs to fill in missing concept spaces in case like knowledge base misses out on some of these cultural artifacts. So we use like self-critique and like it's called collective critiquing and like self-voting. So we use these popular strategies to basically fill in the gaps and also to remove noise from the concept space that we extract. So finally, what we get is something like this: like you have Italian cuisine, and then you have like, let's say, 500 or 600 different artifacts that can be Italian cuisine. So this is not exhaustive. This is automatically extracted, so it is to some extent large, but it's still certainly not very exhaustive. So that's our evaluation, extraction strategy. So we get 300K cultural artifacts for 8 countries across 3 domains. And then we use, so we call it CUBE, cultural benchmark for T2I models. So in this work, we evaluate T2I models, but CUBE can be used more broadly because it is an extraction, a database of cultural artifacts. So we use it to evaluate T2I models, cultural awareness, and cultural diversity. So in cultural awareness, we see how culturally aware are T2I models. So we ask the model to generate image of, let's say, an artifact A from country A, or and so on and so forth. And cultural diversity is something that we define as how diverse the outputs, the T2I outputs are for prompts that are underspecified, or prompts that don't have, like, don't specify any artifact. That's where that's how our benchmark fills in the gaps. So we define a new cultural diversity evaluation aspect, and then we evaluate a new skill. So the first step for doing this is we need to have some very high quality ground truth annotations. So we did this human annotation framework where we evaluated image prompt pairs, and we had the image prompts came from the Cube database, and then the images were generated by T2I models, and then we asked humans to rate the images generated for faithfulness, realism, and also cultural relevance. So we did this exercise, and we got like high quality annotations for a subset, 1,000 artifacts from our data set, and the results we got were, to some extent surprising, but to a large extent, like it is not, it's not something that's new. Like, people have already found this in language models. We saw that obviously there's huge gaps in cultural awareness across models. So we got this 1 to 5 annotations. It's in Likert scale. So if the human generator gives 5, that's the best possible score, and if the human gives 1, that's like you can go back to the slide and see 1 is like not at all. Like, the image prompt alignment is 0. So we saw that there is huge gaps across models. We did it for 2 models, but we found a similar trend for other models on the market. And another important thing is to note here is, like, Global South takes the biggest hit. And also, in our paper, we discussed some of the challenges we faced in this valuation, because different cultures have different standards for realism, and that we had to kind of normalize these scores based on that, based on some approximation. And also getting raters, like we basically used human raters from these countries, and it was important to get to recruit them for high quality annotations. Right. Now, I think we are, yeah, on time. So we can look at cultural diversity, which is something we define in this paper. It's been defined like in previous works as well, but we look at a specific form of diversity. That is, we don't look at visual diversity, but we look at like the diversity of artifacts generated. So that is what we call as cultural diversity. And what we essentially want to do here is to differentiate between the two cases on the left. As you can see on the top, let's say you have a prompt image of American food. You see that a lot of them is like hamburgers and French fries. So that is relatively low diversity in terms of the number of cuisines that there are. And on the bottom, you have like a more high diverse set, like image of Indian foods. You have like a high number of cuisines covered. So that is what we call as high diversity. So we basically don't look at the visual diversity or how these images are presented. We look at the diversity of the artifacts generated. So we define certain properties that we want in a diversity metric. So I encourage you all to read the paper more closely. But some of the important properties here are like evenness. You want, if you have like 6 images and you want to like print out 2 artifacts, it's preferred to have something on the right, like where there's like even distribution, basically higher entropy. And likewise richness, like if you have six artifacts, and if the entropy, the normalized entropy is fixed, you can see that it's better to have even distribution and more coverage, that is richness. You also define something called salience here, that is you want to basically get diversity without compromising on quality. So that's something that we define in our paper, and we basically use the Venn score, which is a recent diversity metric, and that was published last year, and we basically use it to quantify diversity of the cultural artifacts. So yeah, there is a little bit of modification to Venn score. So we firstly normalize the Venn score. So you get a score from 0 to 1, 1 being highly diverse. What it means is if you generate 8 different artifacts and you get a score of 1, there are 8 distinct, 8 unique objects. And if you get a score of, the lowest possible score is 1 by 8, because you have at least one object. So that is the normalized Venn score. And so this is not really important in our case, what exactly the score means. It is, you basically have n objects, and if you can define a similarity matrix k over them, it's basically the entropy of the eigenvalues of the matrix. So what it essentially tells you is how diverse a set of images are, or set of artifacts are. And note that there is this q that is multiplied here. So we use q as the salience, so how relevant an image is to a prompt. So essentially this entire score tells you how diverse a set of images are culturally, but also is it like faithful to the prompt, is it consistent to the prompt. So that's why we multiply q. So you can also have a set of diverse images, but they're not even related to the prompt, right? That is not what we want. So we also generalize, so we also have this, we define different kernels that basically look at different similarity functions. So that can be skipped for the sake of time. Yeah. So overall, I mean, even before we go into diversity, like it's important to see like the geographical inclination of these models. So this is something that we analyzed a little earlier before we define this metric. And you like say have images of landmarks, and then you see where these landmarks come from, and then like geotag them, and then like print out this plot. You look at there's a lot of the representation is skewed. There's a lot of countries in the world that are not covered at all, and there is again across models we found this observation. Now jumping back to diversity, I think we can go directly to the results. So on the left, you can see that we evaluated 4 models for diversity. 1 is the highest, like if you get a score of 1, then you have high quality images and high diversity. And 0, I mean, it can't be 0, the lowest can be 0.125. And that's the diversity spectrum. Again, look at the scale starts from 0.4. So one thing we found was across board there is huge headrooms for improvement, and some of the qualitative images that we have on our paper is like surprising, because for some prompts the images are just like the same artifact in like different angles and views. So there is like negligible diversity for a lot of these prompts. And a split across countries for Imagen 2 we found was, again, there is huge disparities across countries. It's not consistent, but again there is huge headroom across the different countries we considered. And even like some of the countries like USA doesn't have like a 0.9 diversity. It's still, there is still a lot of homogeneity in the outputs for USA. So towards the end, if we do have time, we can also see why this is happening in T2I models, like why is diversity even an objective during the training? Are these T2I models trained to produce diverse images across different seeds? That's something we can see as we go to the next step. I think I'll just wrap up quickly in the interest of time. So the path ahead is to, I mean, given that these models have a lot of societal impact, given that it's like a lot of communities use these models, it's important to build globally inclusive multimodal models. Like different communities would use it for different purposes, and you want the model to kind of have a good understanding of the different cultures around the world. So one important thing I wanted to bring your attention to before we finish was there is this recent work that defines the the Pareto fronts of the three metrics considered. So we also do a similar analysis in our paper, where we basically try to understand the correlation between faithfulness, diversity, and realism. So one important observation we saw was diversity is weakly correlated with faithfulness and realism. This purple graph is the realism diversity correlation mean, and the orange graph is the faithfulness diversity correlation mean. And you can see that faithfulness and realism have a high correlation. So these are like existing metrics, faithfulness and realism. Faithfulness tells you how consistent an image is to a prompt, and realism tells you how real the generated images are. So it's surprising to see that diversity doesn't naturally improve. Like when you have an objective for the model to create very realistic images, it's not it's not always natural for the model to become more diverse. In fact, what happens is when you optimize models for um, realism or aesthetics, that is, you do like this supervised fine tuning for aesthetics, you actually compromise on diversity. The models are produce really high quality images. They look really aesthetic. They look almost like a real image. But when you sample different seeds, you pretty much get the same image. The model tries to stick to the same artifacts, and it's been shown also that with this with the development of T2I models, older generation models have higher representational diversity, and that's been shown in this paper, consistency, diversity, realism, Pareto fronts. So they have this analysis done on different generation of P2I models. So the question we ask is, are we sacrificing diversity for high aesthetics, like high amount of aesthetics? That is something that is important to keep in mind, because like diversity of generations does play a huge role going forward, especially because a lot of um, stereotypes emerge when you have like very homogeneous set of images. And yeah, that was something I had to point out. And some of these early solutions, I mean, all of these works are very recent. On the left is a paper, um, quite recent. It's called No Filter, Cultural and Social Economic Diversities in Vision Language Models. Also, although it's not generative, it is they do this analysis on a SIGLIP model. Then they find out that when they included, so what they also found out was a lot of these pre-training data sets have very little representation for the global south. A lot of these images are image text pairs are in English. So they try to train a model without any filter, without removing images from other parts of the world. And even if they're low quality, they try to include it. And what they saw was on the graph on the left, you see the percentage improvement you get as you switch from an English only data set to a global data set. They found there was some regression on English, but which could be compensated with like fine tuning on English only data set, but you got a huge improvement on global south. So that's an interesting analysis from this paper. They say that just don't use a filter, like include all the data you get. Don't filter out data that is low quality. And they saw that just by creating this data set, you can basically push up these numbers, or the understanding, the geo-cultural understanding of vision language models. And on the right, this is again a recent paper. This is more towards text-to-image models. And note that they basically use Venn score in a different form here. And what you see from this paper is, without any training, just in the inference time, you can actually guide these diffusion models to producing very diverse outputs. So they call this as Venn score guidance. And I mean, I'd encourage you to check this paper for more details. But the crux of this idea is like they kind of do some guidance during the denoising process, and the guidance basically makes sure it takes every new sample away from the existing samples or the memory bank that they keep while generating these images. For a single prompt, you can now get different images across different seeds. This is like an inference time approach, but yeah, the underlying point is solutions need to be multifaceted. Like a lot of countries or cultures don't have representative data sets out there. It's largely, again, it comes down to how the web works. There's like little representation in the web for different cultures. So I think the first step is to build a framework or to build efficient data collection strategies, where you can also represent low resource community, low resource languages, low resource cultures, and then to train models on top of these, and then eventually like make sure you debias these models so they don't pick up like stereotypes. And there's like a bunch of work that's quite recent on debiasing text image models. So that's mostly what I wanted to share today. I hope you enjoyed the talk, and I'd be happy to take questions. You can reach out to me on this platform itself, or you can send me an email at my email.